My name is Tomasz, and I'd like to talk to you about methods, which can be your IDE for Scala 3. But first, let's go through the agenda. I'll obviously start with an introduction. I'll discuss some basic Scala 3 features that we support. We'll see how you can get started with Scala 3 the easiest way. I'll do some short demos. Hopefully everything works. And then I'll discuss some more advanced features that some of them were merged recently. One of the last topics will be explaining what is underneath methods. That will be a quick overview. I'll post more links later for in-depth explanations. We'll finish with discussing the recent work and some upcoming work that we need to focus on. And obviously, we'll end with some questions. And the questions can be asked in the Q&A tab. I'll try to answer them all at the end if we have time. We'll see how it goes. All right, so why am I here? So as was mentioned, I'm working at Virtus Lab as a contributor for Scala Center. And I started working as a contributor for Scala Center to work on methods, which is a language server, which is for Scala, which we also call an IDE because of the features. And I also worked on a bunch of other tooling, all that is connected to methods, anything that we use, methods, and that is, for example, Scala format, loop, some mtags, a lot of different things that we need for a proper tooling support in Scala and Scala 3. But I have not been the only one working on methods. There's been plenty of people who helped. I especially want to thank Olaf, who is the author of methods, and Jorge, whose work on Loop made it all possible. I would also like to thank everyone who contributed, asked questions, raised an issue. Everything is helpful. Okay, let's start talking about methods. It is, as I said, we call it also a IDE because of the amount of feature. It kind of is no longer just a language server, but the language server part of it enables methods to work in a lot of different editors. So, for example, that it will be VS Code, Visual Studio Code, which is the first one, Emacs, Vim or NeoVim, Sublime Text, or Eclipse. Though Eclipse, in this case, is lacking contributors currently, so it might not work perfectly in the most recent versions. But every other editor has more or less most of the features supported, at least as far as I know. I'm not able to use all those editors at the same time, but I think all of them enable you to have a rich code editing experience with a lot of additional nice features. Okay, so let's talk about Scala 3. So Scala 3 is not just the compiler, it's the whole tooling ecosystem, including the IDE. So the IDE is important for any users to actually pick up the language, to start working with it. And it's important both for beginners, for advanced users. It's important for everyone to have a nice code editing experience. And I'm happy to say that we're actually working with the compiler team. We're coordinating efforts when it comes to fixing some upstream issues in the compiler. Methods uses the Scala 3 compiler. We're trying to make sure that every release of Scala 3 is available to use in methods as soon as possible. We'll be trying to improve that further on, and I see a bright future ahead of us because we have a lot of great ideas how to make it all work much more seamlessly for the users, and that's it. Yes. Let's talk about actually Scala 3 support. So Scala 3 support was based on the Dotty language server, which is in the compiler workspace itself. First approach to supporting Scala 3 was just copying over the .language server to the Metals code base and reusing parts of it for the Scala 3 support. It has evolved heavily since then, but still depends on the compiler for a lot of the features. So that's why we're contributing fixes also upstream. And but it's a much more richer experience now than it was with the .language server before. Let's talk about some basic features. So as I said, one of the basic features are completions. So a way to figure out what you can write. For example, if you have in a planet, you want to know what planets you can write, stuff like that. So you'll get auto-completed suggestions on how to write your code. And currently, most of the functionality is on par with Scala 2. We're missing still some custom completions. I'll talk about that later. But completions are improved with each release, and we're trying our hardest to make them the nicest possible features to use. Another basic feature is hover, which allows you to see some information about a symbol, such as whether it's an enum, whether it's a vowel, what type of vowel, and you can hover over a particular name and see what it is, or you can use shortcuts to pop the hover up. You can show the hover even using keyboard. And we also try to include some specific Scala 3 information, such as information if it's an extension method or if it's an enum. This way, users are better informed about, it's easier to see what's going on in the code. Another basic feature that enables the navigation around the code base is definition, go to definition. It uses information from SemanticDB, which is a file that is generated during the compilation that has all the information, what symbols are the same symbol and where they are located in which files, which enables us to quickly show you the definition of anything that you need. We also have a fallback to the compiler in case, because SemanticDB files are actually created during compilation. So if the compilation hasn't finished, we also support trying to find the go-to definition using the compiler, which has an ability to even work on a non-compiling code. So that's we have this kind of a fallback. A companion to go-to definition is references, which searches all references to a particular symbol that you might be interested in. And it also uses SemanticDB. It only uses SemanticDB currently. So it needs compilation, but thanks to the fact that it's done during compilation and that is kind of already possible to use just after you compile the code base, it's quite responsive and it's really nice to use. Based on references, we have renames, which you use references to rename particular symbols. So if you want to rename, for example, here, planet to planetoid or any kind of name you want, it will use the references and will also quite responsively change all the names in your workspace. It will also work currently with symbol overrides because starting with Scala 3 version 3.10, which recently added more information to SemanticDB that we can use to find the implementations and every information about the type inheritance. Okay, so those are basic features. I just went through those quickly because a lot of people already know them, and but it's important to note that it all should work within methods and that we are improving constantly. But how can you actually get started with Scala 3? So there's a bunch of options. So one of the options is using Cursor. You can use this templating engine called Guitar 8, which is also used by SBTnew, and you can do just use it to set up the Scala/Scala 3 G8 template and just go into it and start coding. There's a mistake. There should be Dotty, but Scala 3 did but just a small mistake here. So another option of creating a Scala-free project would be via a new project wizard that is possible to use in Metals. And it's whenever you have an empty workspace, you can click on a button in the Metals view, or you can invoke it from the Metals view. Actually, all the time there's a small button. I'll not go through it currently, because the thing I wanted to show you is that you can actually currently start using Scala-free by using this new tool called Scala CLI. And probably it was mentioned a lot, but what I wanted to mention is that it already works with Metals, and we're able to provide the same experience with any other build tool that you might use normally to Scala CLI. So the Scala CLI also supports Scala 2, so it's not only Scala 3. And it does support Scala Native and Scala JS. Okay, let's try quickly to see how we can actually set up this Scala-free project using Scala CLI. So let's try, for example, making a demo directory. Then we can go to that demo, and let's say we create main.scala. Then we can try to, maybe it can be a very simple class, or that main definition. We will just do print line and do hello world, and see if I didn't make any mistake. Last time I did a lot of mistakes. And I have Scala already installed, and you can actually do or use that command. So this will run this current directory, so any file in the current directory. So if I have only one main method, it will run just that with a Scala version 3.1.0. Let's see if that works. Oh, yeah, that works. And now you can actually go and open up Metals, see that file, and make it bigger. Let's make it bigger. And you can see that Metals server is starting, so it might take a while, because only when you open the Scala file, it notices that it's a Scala project. In this case, it's because we don't want to open any other projects in case somebody has other projects, Python projects, and we want to only open Metals in a Scala project. Okay, so we should actually be getting something. Do we get something? Still being indexed. Yes, it's being indexed. Probably because I'm sharing it always makes it much slower. But what is happening here is actually that we got Scala key generated this JSON file, and that JSON file tells Metals how to use what to use. So it can start Scala key in the background, and you can see you can do hovers, you can do print line now. Yeah, it will work now. You get completions, you get probably should get go to definition. Yeah, we went to prediff. So yeah, everything seems really, so it is really quite a seamless experience to get started with Scala using Scala CLI, and it already works with Metals. There's one issue that I'm helping out fix, that currently using this workflow running will not work, but it's a small issue that since it's a new tool, it's obviously still some small features to work out, but it's amazing already that this all works very fast. Okay, so that demo worked. But Metals can actually be used in a bunch of different ways. So it can actually be used as an online IDE. So there's GitHub code spaces which I think are still beta, but there's a thing called Gitbot that you can actually use to open any workspace within that Gitbot application, I could say, and that will look exactly like VS Code. It actually is using currently the same VS Code implementation that you have on desktop. And I have a small experiment. So there's, let's see. So if we go, you can actually see, oh no, this time out. But I created previously a workspace, and you can actually share that workspace with everyone. And hope we see it. So my plan here, let's see. So I created a thing called Creative Scala, and it's based on the Creative Scala course that is used for Scala Bridge, and it uses the Doodle library. And I created this Doodle library, and I didn't create it. I created this small piece of code that tries to get some of the shapes and make a mosaic out of those. And you should actually be able to, let's make sure this is actually being, so you can actually see methods should work perfectly fine here. Yeah, you already get syntax coloring, there's terminal, things seem to be working. Can make it again bigger. So maybe that's too big, but let's see. And oh no, obviously something broke. But we should be fine if we should be, this actually should be, no, it's actually being shared. So you can actually join that workspace. I asked a colleague to join and print the link. So hopefully he does that, and you can join the workspace. You should be able to add a new shape to it. So we have like a square, we have a circle, and I will try to later get all those shapes in here and make a mosaic. If we have time, I'll try to do it quickly. But yeah, let me try to connect again, because obviously it worked every time I joined previously, but it doesn't work anymore. Let's see. We can do connect to build server. That should work, unless something weird is happening. No, it starts to work. Okay, cool. Yeah, it started working and has run debug. Okay, cool. So I'll be able to work with it a bit later on. So I think it's a really nice thing to be able to work on the same workspace together. You can actually use the known extensions, all the known extensions for VS Code, including LiveShare. So somebody could work inside Chrome browser, and somebody could join you using a normal VS Code, and it should work all together. So it's also easy to get started. You just click on something and you can experiment with methods. You can obviously experiment with any other extension for VS Code. It all should work correctly, unless everything breaks. Let's see if too many people join, if that becomes an issue. Okay. But I talked a bit about some basic features. I talked a bit about how to get started with Scala 3, but let's talk about advanced features. One of the advanced features is running, debugging your programs. And it does work with Scala 3. It does work with the new main annotation. So it will allow you to use code lenses, but there's a bunch of other things, other ways to actually run programs. And you can find more in the docs. I'll try to, in a second, show some of them. We're still working on expression evaluator for Scala 3. We recently merged one for Scala 2. but we're still working on Scala 3 support, which should be coming in the coming months. But I have a workspace here that's already set up, and now we can actually see if it all works. Let's see. This all should pop up here. Let's see again. Now everything stopped working. Let me just quickly see. So there's a command that usually fixes most of the things. That's connecting to the build server. And we should actually, okay. Oh yeah, now it works. Okay, cool. So if you, no, it doesn't work. Yes. Right, so that running does work. Probably clicked it many times now. You can also do breakpoints. And this will stop here. There's other ways of running the code. So one of my favorite is that you can actually run this command. It can be, all the commands in VS Code can be tied to shortcuts. And this one will run the main class inside the current file. So here you go, it's the same, and it runs it. So this is another way that's very useful, quick. And there's a similar command for tests. And you can also use this tab here to specify. Can do main class. This is, we don't need a build target. We can actually do main, debug main, and this should actually work. Okay, then find class main. I will not be debugging right now. I know. I named it a package. We can actually quickly see that here. And it's an example.main. And if that works. It's trying to work. Yeah, that works. It didn't show up it's too little space, I think, at you can see debug console. I'll do it again. And it is running again. So all those things should work currently in Scala 3, except the expression evaluator, which we are actually working on currently. Right. Another thing I wanted to talk about is kind of a lot of people disagree about it, and this is the automatic fix for indentation whenever you paste something. So we try to adjust the indentation based on the current position of the cursor, and for the most part it works. It's the only problem is that sometimes if you don't have the full line selected, we don't know what indentation you actually start with. So the indentation might be of the later lines might be actually bigger than what you expect, but that is actually not an issue. It will still compile. The code will compile. So it's much better than the alternative that if you just copy paste any code, it might break your optional braces code, because in Scala 3 you have optional braces, so indentation matters. So it's important that the code that is copied over still works correctly. We disabled it for now because it's still experimental. There's this additional setting called metals enable on paste, and I can quickly show that here. Just so if you, for example, get this, and so the cursor is located here, and it will adjust. If I didn't actually adjust it automatically, it would look like this. So this this no longer compiles. This breaks. Yeah, not found F, so this breaks. But with what we do automatically, the code will still compile. So I think it's a pretty useful feature, though it's still expensive. We want to make sure that we work out all the possible issues. Connected to pasting code is Scala format support. So my colleague Mariam talked about a lot of the nice tools we're using. I don't want to repeat that. I just wanted to mention that Metals will try to automatically set up everything for you when you use Scala 3, because in Scala format, you need to specify dialect for Scala 3. In the future, you'll also need to specify dialect for Scala 2.12. So we'll also make sure that that is handled. We'll try to make sure that if you have multiple versions of Scala within your workspace, that we will add those file overrides. So there's different dialects for each version. And this is done automatically whenever the Scala format file is created, or if there's an issue, we try to also automatically adjust it. And we always use the most recent version, and you'll get, hopefully, good experience using Scala format. And because we do need Scala format file for the auto formatting to work correctly. I can, again, quickly demo this. So I actually added Scala format file here. I can delete it. And if I delete it, and by this, then you get an option to create Scala format file. It got created. It will be different because I modified it, but it already has the dialect. It has the most recent version that Metals has, and it will work correctly. If you have a works with multiple versions, so if you look at this, what I have here, this is automatically generated for the Metals repo itself. So it still works after I remove the Scala format file for the Metals repo that is there. And if I try format again, it will automatically fill everything and make sure it still works. Another connected thing to Scala formatting files is organizing imports. So this is done in Metals using this additional Scala fix rule called organize imports. It works for the most part, except given imports, which actually have been recently released with a fix for given imports, and we'll include that in the next Metals version. Until recently, you had to also save your file in order to have it, the file organized, but currently it also works on unsafe code and should work without issue for all the needs you have. Good thing about this type of organized imports that we use with Scalafix is that you can configure Scalafix to work on CI to verify that every time you do a modification, you do a PR, that the imports are correctly organized. The only thing that will not work for now is unused imports. We depend on the unused imports flag in the compiler, which is not yet added to the Scala 3 compiler. Okay, one of the nice things that were recently added, and this is thanks to some great work by Regito Taniguchi in the compiler, is type decoration. So type decorations are ways to show this virtual text that shows up next to vowels, defs, anything that has the type inferred, and shows the real type there. It uses semantic DB information, and that information was added by Regito recently to the compiler during the Google Summer of Code. And you can bind it, turning it on to a shortcut. There's a command called toggle inferred type. You can bind it to a shortcut to show it, to hide it, and it's pretty nice to use. Let me just show it to you quickly. So for example, I think I know typeset a bit. You can see it's actually shown here. I have a shortcut that disables it. You can do toggle showing inferred type. And it's also a setting within Metals show inferred type. This is modify it here. Turn off, turn on, and we'll refresh. So and it worked previously for Scala 2, but it now works also for Scala 3. Another amazing thing that got recently merged is source file analyzer. It's our name for a way to view your Scala files decompiled in a different way. So it can be using JavaP. We can show the semantic DB representation of your file. We can show Tasty. Tasty is a file format connected to Scala 3. I don't want to get into that, but it might be very useful, especially for anybody working on macros or the compiler itself, to look into what Tasty has in it. For example, it contains the AST of the code that is how it's understood by the compiler. We'll also soon have the Java decompiler, which there's a PR waiting to be merged, and that should be available in the next version. Let's quickly see. Okay, if we, for example, do show semantic DB detailed, we'll get all the information of how Metals actually sees our file. We can do, since it's Scala 3, we can actually do show decoded Tasty. You can see how the Tasty looks like. You can see the trees. You can also do the JavaP. Oh, I think I clicked on the. Let's see, JavaP, verbose, but actually it's the slowest one because it actually needs to invoke JavaP, but that also works. So it's very handy for people wanting to learn more about the code, to see what's going on underneath all that syntactic sugar Scala has in it. Right, the last one of the advanced features I wanted to discuss is Worksheets. Probably not to show a demo, we don't have that much time, but this is allows you to quickly experiment with the language, with the workspace. You can create worksheet files standalone, and you can just experiment with those. You can also try to create them in a source file, next to source files where all your source files for your project exist, and you can use any class, any type from that. This is really nice to experiment. You can easily even use a command to quickly create a worksheet called create worksheets, and infer type based on the package, and you can just experiment with it there. Okay, so those were the advanced features I wanted to discuss. All of them are available for Scala 3. But let's see what's actually going underneath. I'll go quickly through what are the protocols we are using in Metals. First one is the language server protocol, and it's a way for editors to ask the different servers about the code. So it uses JSON RPC, so it sends JSON back and forth. And for example, if you're in a piece of code and you want to know what are the completions, the editor will prepare a request for you, send it to the server. The server will analyze the file and get some answers. So here we got adding additional, both are correct answers. That will be sent back to the client editor and presented to the user. And you can apply that completion later on. This works. This is why it works in so many editors. Each editor knows how to handle that JSON RPC protocol, language server protocol. Another thing that we use in Metals is the build server protocol, which is kind of a complementary protocol to LSP. and it enables us to talk to many different build tools. There's 4 at least that are currently used within Scala, which is Mill, Gradle, SBT, or Maven. We support all of those, but at the start was like, how can we actually support those? And BSP is our answer to that. So we actually talk with all those different build tools via the BSP protocol. There's different ways to do that. I'll go quickly through all those build tools to see how they're supported. So, for example, SBT can work directly. We can set up a server, and you can actually, methods can talk to that server via BSP, but it can also generate configuration files for this additional Bloop build server. And that build server is different from what SBT is doing in regards that Bloop is just one server for the entire machine, while SBT will start a server for each different workspace. So if you have a lot of different workspaces, metals, it's best to be used with Bloop. While if you, for example, just work on one single workspace that has complicated SBT build, you might want to use BSP SBT. So just start. There's some blog posts that you can read on our website to see how to start SBT, and you can reach out to us with any questions you have. Another build tool that supports both Bloop and BSP is Mill, and there's also work to make it even better. There's a PR being currently worked on that adds a bunch of features, including a way to you should be able to actually work with your build definition files in Mill, which I think is pretty handy. And it can also, obviously, as I show here, generate Bloop configuration files, whichever you prefer. For Maven, you can only use it with Bloop, so you need to start first metals. Then it will try to import the build definition from Maven and start Bloop. And it's quite nicely supported by Bloop currently. I did some work to make it much nicer, and it's supports Scala 3 already. And the last tool, it's used by a lot of people, is Gradle, and it's also only working via Bloop, and it only supports Scala 3 from the next version of Gradle that will be released. We did some work around that, and so Scala 3 will be supported soon, but not yet in the current version that is released. Right, so how does it work? So it's very similar principle. Instead of the editor and LSP server, we have LSP server and BSP server. And whatever information LSP server needs about the build definition, for example, which project source file belongs to, and will ask the BSP server. The BSP server will think about it, answer, and maybe LSP server wants to compile that project. It will send a request to compile it to BSP server. The BSP server will take a bit of time to compile it, and maybe it will create an error report. That error report can be analyzed by LSP server and presented to the user. So it's very similar to how LSP works. There's some in-depth talks about it by Chris Kipp. I'll have a link soon about it, but if you want to learn about it, there's plenty of talks about it. There's plenty of information. If you want some guidance, want to learn more about it, do ask us on Discord, on Gitter, or discussions on GitHub. We're happy to answer all the questions. Okay, so let's see what was the recent work. So we recently merged this, released this big 0.10.8 release. It has support for expression evaluator, unfortunately not yet for Scala 3. It can show type on selection. So whenever you select some kind of code, you can learn what is the type of that expression. There's this nice new feature that you can search for all your dependencies for text files and certain strings within it, which was contributed recently and is a really amazing contribution. And we obviously did a lot of nice Scala 3 improvements there. We don't have time, unfortunately, to look at those, and they're not really related to Scala 3 yet. I am working on type on selection to work with Scala 3, but I haven't had the chance to finish my PR. Expression evaluator is also being worked on, so that should be available in the coming months. Another thing that we need to work on are some custom completions. So for example, if you want to have match case completions that would automatically fill in all the possible types, still not available. There might be some Scala 3 specific completions that we might want to do. We don't know yet. There's the expression evaluator and maybe some refactorings that need to be still implemented. But if you have any ideas that you would want to see in methods, don't hesitate to ask us, send us those ideas. This is actually a screen of our feature requests from a couple of months ago, or a year and a half, I think. And this is it now. So you can see it actually changed. A lot of the things were implemented. There's different things at the top. And we're working on both of those top features. So we do try to listen. We do try to implement things that you need or want to use. There's related talks by Olaf, who is the creator of metals. That's really interesting on last Scala days. There's some great explanation by Chris, some in-depth of how metals works. There's also, he did also a lot of information, added a lot of talks about Vim, because he's the author of the plugins for Vim. And if you want to get the real basics, I did a small 18-minute talk about it that you can find under those tiny URL links. I tried to make the links readable here. You can ask them. I'll try to link the slides later on, so you'll be able to just use that. Okay, so let's see if anything actually happened with the creative Scala. So if did anyone square with. So we do have things, and we can do square, circle, and do, there's a triangle already added, star. Right, so we've got this. And let's see if we can make this mosaic out of it. So this is running. Okay, that didn't work. So unfortunately, that didn't work. It would be cool if it worked. There's I have a demo that worked previously, that did something like that. Unfortunately, I think the library Doodle is released for Java 11. I think I thought I fixed that. You can actually see Gitpod. Yeah, it should be 11 here. It didn't work. Unfortunately, we don't have time to fix it. Yeah, let's get back to the talk. So yeah, that's actually all I wanted to say. My presentation will be available under this link. I'll try to link it in the chat or on the Slack. You can read more about metals on our documentation. You can read about Bloop. You can reach to me on Twitter, and you can talk to us on Git or Discord, GitHub, anywhere you want, anywhere you feel comfortable talking. And that's it. Thank you for listening. Hope it was useful for you. If you have any questions, please ask.
Hi, thank you so much for your talk. We have time for just a couple of questions, so let's jump into it. Where does the name metals originate from?
So there's the organization Metals is in. It's called Scala Meta, and so there's Meta part, and LS is language server. So like kind of a meta language server, metals. It's I think it's a nice name anyway, and this is kind of an explanation, but also the name was nice, so that's why.
Absolutely. Okay, our next question. Are there any plans to show implicit hints as per IntelliJ for Scala 2? It would really help identifying the old style implicits in Scala 3 code bases.
Yes, for sure there are plans for that. I need to check whether it's all included in Semantic DB or not, but Rikito has been doing a lot of work in that regard. He did some PRs that I'm not sure currently were merged, but for sure we plan to support everything that we support for Scala 2. And also there's a bunch of things like, for example, we'll be able to show given names for any like anonymous givens, or we'll try to show you whenever you have using anonymous using, we'll try to show the name and try to show where it's actually used by your code. And so we have a bunch of plans to add some even more ways to investigate your code, more decorations and more. There's a lot of plans. We haven't been able to do everything because there's so much new stuff that we want to do, but there's for sure plans to do that.
Great, thank you so much. What great questions and what a fantastic session. Thank you again, and I really hope you get to enjoy the rest of the conference, and let's connect on how to get the remaining questions answered.
Okay, thank you.
Thank you.